Welcome to today's deep dive. You know, when you're watching like a massive global broadcast, maybe a championship game or something.
Yeah, or a huge stadium concert.
Right, exactly. There's this invisible tightrope walk happening behind the scenes. And the safety net keeping that whole broadcast in the air, it's often just a single 25-pound piece of hardware.
Which is wild to think about
Yeah.
because in live broadcasting, latency is basically friction.
Oh, totally.
Yeah, the moment the video processing starts to, drag even a little, the whole illusion of it being live just falls apart.
And you get that terrifying drop into a black screen.
Right, that is exactly what broadcast engineers lose sleep over.
Okay, so let's unpack this, which brings us to the Kiloview KVW-MAX 64 NDI core.
There's a mouthful, yeah.
It really is. It's a video management server, but it comes with a nearly $8,000 price tag.
Wow.
Yeah, so today our mission is really to demystify how this specific, massive piece of technology prevents those ultimate live streaming nightmares.
Well, to really understand that $8,000 price tag, you have to look at the intense physical hardware required here. I mean, routing uncompressed video is no joke.
Right, so we're not talking about a standard desktop computer then.
Oh, not at all. It's a 25.6-pound rack mount server. It runs on a customized Linux OS,
Okay.
and it's packed with an Intel i7 8-core processor, 64 gigs of RAM, dual 10-gigabit SFP, plus fiber ports.
Wow, fiber ports.
Exactly.
Yeah.
And it even has a redundant battery power supply. And get this, a water-cooled radiator.
Wait, okay, I have to stop you right there. I mean, I get that live video is demanding, right?
Yeah.
But a water-cooled system just to switch between different camera feeds?
Yeah, it sounds like a lot.
It feels like massive overkill, like buying a factory-tuned race car for a grocery run. Why not just run a robust software app on a high-end Mac or something?
What's fascinating here is that switching is actually a massive understatement. The core in the name. It stands for control, organize, route, and more.
Oh, I see.
Right, so this machine isn't just cutting between a few pre-recorded clips. It is actively routing up to 64 independent feeds.
64.
Yeah, of pristine 4K resolution video at 60 frames per second.
So, okay, the water cooling isn't just for show then. I guess if you tried to push that much continuous raw 4K data through a standard processor,
It would basically melt. Well, it would physically overheat and throttle down, inevitably.
which immediately brings back that latency friction we were just talking about, right?
Precisely. And it's built as a turnkey system, meaning you buy the box, rack it up, and it just works.
So you skip the frustrating setup.
Exactly.
Yeah.
Broadcast engineers don't have the time to mess around with Docker deployments.
Right, which is basically just a fancy way of saying manually building software containers so different apps play nice together.
Yeah, exactly. This turnkey approach means you skip all that hardware compatibility testing entirely.
That makes a lot of sense. So all that water-cooled hardware sounds like overkill until you realize exactly what it's being asked to juggle.
Right. Imagine the processing load of taking 64 separate 4K camera feeds and orchestrating them without a single dropped frame.
Or a blurred pixel. But okay, here's where it gets really interesting to me. It manages up to 64 NDI inputs and outputs simultaneously, right?
Yes, using NDI, which,
Okay.
for those who don't know, is Network Device Interface.
Right, that brilliant protocol that lets you send broadcast quality video over a standard local internet network.
Yeah, rather than having to run, thick dedicated SDI cables all the way across a massive stadium.
And it handles both full NDI and NDI-HX, the high-efficiency version. Plus, it mixes horizontal and vertical video seamlessly.
It really does.
But practically speaking, how does a single human operator actually manage the chaos of 64 simultaneous feeds? Like, if I'm at a desk, that's pure visual chaos.
Oh, absolutely. But if we connect this to the bigger picture, think of the software less like a traditional switchboard
Yeah.
and more like an automated train switch yard.
Okay, an automated swish yard.
Yeah, the moment a new camera connects, the system automatically detects it. It identifies the train car and puts it on the track.
Oh, wow. So you don't have to manually hunt for IP addresses in the middle of a live show?
Exactly. You configure everything through a visual crosspoint or I/O panel. It's basically a digital grid.
Right. So you just click the intersection of, say, camera 3 and output A, and the route is instantly set.
Yeah, and you can even set up automated playlists for polling. It loops through different video feeds completely hands-free.
That's incredible.
They've effectively taken an entire broadcast control room and shoved it into a 19.5-inch box.
So what does this all mean for you, the listener? Well, the next time you're watching a flawlessly smooth live stream, remember it's powered by incredibly robust, highly engineered machines like this.
Doing all the intense physical lifting behind the scenes.
Exactly, so we never get that dreaded black screen. But it does leave you wondering something pretty wild.
What's that?
Well, if a single 25-pound server can flawlessly route 64 live 4K streams today,
Oh, I see where you're going with this.
right, how soon will the massive multi-room broadcast studios of the past be entirely replaced by a single quiet rack of water-cooled servers sitting in a closet?
Yeah.
Definitely something to think about.